Wave-particle duality is one of the most fundamental concepts in quantum physics. A photon moving at the speed of light can act as both a wave and a particle. This strange phenomenon forces us to re-examine our common conceptions. There are a lot of experiments, theories, concepts, and misunderstandings in this topic. To understand duality, it's worth looking at the difference between a particle and a wave. We can imagine a particle as a marble on a smooth table, and when a force is applied to it, it moves in the direction of the resultant force, obeying Newton's laws of motion. They have a definite mass and volume. These particles can arrange in different configurations to form matter. On the other hand, waves are more of a disturbance in the medium. They have no mass or volume but can be defined as the motion of energy. One of the best visualization of a wave is the ripple formation on a pond. The disturbance in water travels as a wave spreading out over a large region. We can see that both are completely different things. Then what is the point of duality nature? People thought both are two different things until the polymath Thomas Young conducted the double slit experiment. This experiment involved shining a beam of light on two narrow slits and observing the outcome. When light is sent through two narrow slits, we expect to see two narrow beams of light formation on the wall. But this wasn't the case. We were able to see more than two beams of light. This confused a lot of scientists, including Young. But why does this happen? The explanation at that point was that light can diffract and undergo superposition, resulting in the creation of more than two beams of light. This proved the wave nature of light. This partial truth wasn't broken until the beginning of 20th century. Hot objects radiate radiation in all sorts of wavelengths. These radiations are called blackbody radiation. The problem was all these theories at that time pointed to something strange. Light rays emitted beyond the blue ends of the spectrum would have infinite amount of energy. But we all know it is impossible to radiate infinite amount of energy. Scientists call this the ultraviolet catastrophe. Many different theories were proposed to solve this problem, but none worked out. Until a German physicist, Max Planck, came up with a different approach to this problem. He proposed that light is not continuous, but it is composed of large number of particles. These particles were also given a name, photons. This idea solved the ultraviolet catastrophe and gave birth to quantization. As one problem was solved, other issues started to emerge. If light can exhibit both wave and particle behavior, can other fundamental particles do the same? Or is it limited to the microscopic world of atoms and photons? A more recent form of Young's experiment was conducted by firing a beam of electrons through narrow slits, observing the diffraction of the particles just like a wave. The intriguing thing about this experiment was that electrons striking the wall won't deposit their energy all over the wall, just like a wave crashing onto a shore, but it acts like a tennis ball striking a window. They travel through the space in form of waves, but at the instant they act like a particle. Now the question is, why is it limited to the microscopic world of atoms, electrons and photons? Or are we only seeing one aspect of it? This is where Heisenberg's uncertainty principle comes into play. For everyday particles such as grain of sand or a tennis ball, the wavelengths are so small that their location can be measured accurately. But for small particles such as atoms, electrons and photons, this becomes more challenging. As the famous physicist Richard Feynman said, "I think I can safely say that nobody understands quantum mechanics." I think this is true to this day. Nature always has something up its sleeve to leave us astonished and confused. As we continue to explore, who knows what other secrets we'll uncover about the nature of reality. Until next time, keep questioning the mysteries of the universe.